So a super simple warm-up that'll lead into today's lesson. Find the area of the shaded figures. One's a disk, like completely filled in with r equals 7. And the other is, what name would you give that shape? A donut. That's fair. What we usually call them in calculus is a washer. Because washers are usually flat, suggesting more of a 2D shape than a donut, which is more of a 3D shape. With an outside radius of 5 and an inside radius of 1. So find those two areas, the two shaded areas. So I hope you got that as an answer. 49 pi for the first one, 24 pi for the second one. Yeah, if you did in the calculator, that's fine too. Absolutely. And then maybe arguably better because the calculator is what we'll be using today. 49 pi, 153.938. 24 pi, 75.398. Absolutely okay because we're definitely using the calculator today. Any question with those? Just big square, big circle minus little circle. Now, I hope that was easy because yesterday we were adding up squares, triangles, semicircles. Today we're going to add up circles and washers, or discs and washers. Now, they're going to be built a little bit different way, or like where they come from is a little bit different. Solids of revolution. So we're going to take a 2D figure, rotate it around an axis, and create a 3D figure. And there's some YouTube videos that show this pretty well. Volume created by revolving a given area or a given base, to use the same vocabulary from yesterday. You get some base area and revolve that around a given axis. Excuse me. Thank you. Two types. Disk type, meaning there's no hole in the middle, and washer type. Ones that do have a hole in the middle. But they're not that different because they're both circles. They're both pi r squared. One just has a missing circle in the middle. So they're a whole lot similar than most times you say, oh, there's two types of problems, they're different. Here, yeah, they're different, but they're not that different. The washer just has a hole in the middle of it. So Roman numeral 1, disk problems. Not to make this sound too simple, but we're going to add the disks, or the circles. Like yesterday we added up the squares, then we added up the triangles, then we added up the semicircles. Today we're going to add up the circles. But building the volume is different than yesterday. So let's have our area bounded by y equals square root of x, y equals 0, and x equals 4. And let's rotate that area around the x-axis. Alright, so let's draw the base, and then we'll worry about how to draw the rotated thing. So square root of x, I know what that looks like. I'm only going out to 4, or I'm going all the way to 4, I guess depending on how you want to phrase that. And the square root of 4 is 2. I like to shade the base area, not completely necessary, but we're going to draw some more stuff on this picture, so it, I don't know, helps me to see that's the starting point. All right, some drawing hints, because part of this is an art class. If you can draw the area, it helps you understand what you're trying to find. So some drawing hints. First would be reflect the base across the axis of rotation or revolution. So maybe I should have started the first hint with highlight the axis that you're going to rotate around. And then I'm just gonna reflect it like a 2D picture. I'm going to reflect it, so get my key points on there. So now I've reflected it to the other side. But it doesn't just reflect over there. What happens is that whole picture, that whole piece got rotated down. I'll show a picture in a minute. Hint number 2. Draw 3D circles. You'll see what I mean by that. Like, how is a circle 3D? On each end. So like perspective circles. So like circles, but they're like flattened, because now I want this thing to look three-dimensional. I guess number 2 sort of needs an if possible, because I can't really draw a circle on the left end. And then lastly, draw a 3D circle in the middle. So somewhere between the two ends, just pick a spot and draw a circle in there. So can you visualize what this shape is now? Someone want to try to describe it? I heard a cone. It's kind of a rounded off cone. Any other descriptions of what you think that looks like? A volcano, like a sideways volcano, though, yeah. No one wants to say a bullet, I guess, but that's what I think when I see that. Let's look at the 3D sort of rendering of it, or pretty close to it anyway. So this is not going to be exactly the same, but it's pretty close. Oops, that's not what I wanted. There it is. So there's square root of x. They're also doing an extra line in here, 1/10 x. They are going to stop at x equals 4, though, if I remember right. X equals 4. So there's their base area. And then they're going to rotate that around the x-axis. Yeah, I'm not cool enough to draw that. But with a 3D picture, you can see a little bit better of what's going on. And then there's their slice, and that one happens to be a washer because it has a hole in the middle of it. I think that's where our little animation ends. Or maybe he slides it back into the... Nope, that's it. So simple little animation there to help visualize disk method, washer method. As always, YouTube has all the answers. Oh, here it goes again. I don't know if we need to watch it again. Square root of x, 1/10 x. That's what is going to make this be a washer problem instead of a disk problem, is this line right here. Again, he follows the same order as we do. His picture is a whole lot nicer than ours. Draw the base, and then as best you can, visualize and rotate it around the axis of rotation. All right, enough of that video. Let's go back to our picture. Not quite as good, but it's not bad, right? Like, that looks pretty good. So if I take this slice out of there, take that slice out, that's a circle whose area is pi r squared. And so yesterday we summed all the squares, semicircles, triangles. Today we're going to sum all the circles, or all the disks. Later we'll sum all the washers. So sum, remember that means the big S. So I'm going to add up all the pi r squareds, and the thickness of that, it's super thin, but its thickness is dx because it's an x slice. You know what? I'm going to make this a capital R, and you'll see why a little bit later. It doesn't matter, but I'm going to call that capital R. So in my picture, there's R. But kind of like yesterday, I can't really integrate r squared dx. That doesn't really work. I need to know what big R is equal to. Is that an x distance or a y distance? It's a y distance, and it's measured from the x-axis, so r equals y. So that radius is y. But it still doesn't really work for my integration because I can't stick a y in an x integration. So what does y equal? Square root of x. So let's integrate pi times square root of x squared. And that would be from 0 to 4. And you could go type that in the calculator right now, even though square root of x squared would just be x, but I'll leave it up to you. I'm gonna do the algebra on that because I think me doing the algebra is easier than me handling all the parentheses in there. Pi times x dx. And let the calculator do the work. So my volume is 25.133. So you get the connection with yesterday, how it's the same, adding up the slices, but it's different because they weren't built by slices, they were built by revolving something. All right, second type, and then we'll switch to a worksheet with a ton of examples, and we'll just see how many we get through. Washer problems. So just like we did in the warm-up, the area is pi times big R squared minus pi times little r squared. And that's why I picked big R on that last example, because Usually big R is the outer radius and little r is the inner radius. This time, let's say our area is bounded by, you know what, let's make it match that problem we just watched on the video. So that was y equals square root of x, y equals 1/10 x, and x equals 4. So I can do the square root one pretty easily. X equals 4 is pretty easy. 1/10 x, that means when I'm out at x equals 4, my y value would be 4/10, so my y value would be pretty low. So there's my base area. Again, we're doing the exact problem that we looked at on YouTube. And let's rotate around the x-axis. By the way, once we get going on these, we'll start rotating around all sorts of things, but the x-axis is probably the easiest thing to rotate around. Alright, so thinking back through my hints, I'm going to reflect the area first. So reflect the base area first. And then I'm going to draw circles, 3D circles at the ends. Can't really draw one at the left end because it reaches a point. And then somewhere in the middle, 2 circles there. Alright, so you have it drawn and maybe visualized, hopefully visualized, because it's the YouTube video that we watched, so we have a good feeling for what that shape is. All right, that washer, I want to add the washers, and it's washers all the way down. It can get crazy and have some disc and some washers, but most of the time it'll be all one or the other. So I want to sum the washers. From 0 to 4, and I'm slicing dx, or the thickness is dx. And so now I need to figure out what's the outside R and what's the inside R. It's just y1 and y2. The outside R is y1, or the square root of x, and the inside R is y2, 1/10 x. And if we had put this in the calculator, we could use y1 and y2. We didn't graph this in the calculator, so I'll need to stick with the x stuff. Let's see. Big R is square root of x squared minus 1/10 x squared. So, see if you can get that in the calculator with all the parentheses and squareds and everything in the correct spot. You can type it in as is, or you can do a little bit of algebra if that's easier for you. Like the square root of x squared, I know that's just x. Now, I didn't do any of the other algebra. I could have typed in x squared over 100, I guess, but let the calculator do the algebra, unless it's easier for you to do the algebra than to type in all the parentheses and stuff. All right. I kind of like this unit because I like drawing all the pictures, but that's just me. So we'll do some of these together. The little calculator up there indicates that you can use your calculator. For the following problems, draw the curves, show the mirror image, so that matches the hints that we were talking about, the mirror image about the line of rotation. If it is a disk problem, find big R. If it's a washer problem, find big R and little r. Then write and compute the integral of the volume of rotation. And so all of these have a blank for big R and little r, but sometimes there is no little r because it's a disk, not a washer. Again, I don't know how many of these we'll get through. We'll get through some of them. We'll probably do all of number 2, and then we'll just kind of hop around and see where we go. But online, I've got all of this with answers, all of the examples done, and all of the homework done. So if you want to see tons of examples, they're there. Why don't you try 2A? Just start to finish on your own. Graph it, draw it, and then figure out what the circles are. So there's the picture. There is no little r. I'm going to press pause again and see if you can finish it out. So r is y1, which is 2x. It's also helpful to see or understand that big R is changing. Sometimes you'll have ones that don't change. But big R is changing, so it needs to be a function of x. As x changes, big R is changing. Integral from 0 to 3 of big R squared. So that would be 2x squared. Whoops, with a pi out front. dx. 113.097. Many of you already started, so take a minute and see if you can draw. Try it if you want to, but at least draw the one in part B, because it's a little bit different, has a different axis of rotation than we're used to. So see if you can draw the one for B. So probably the best explanation, not my own, is that this is a cylinder with a cone missing from the middle of it. So if I look at my washer, I do have a little r and a big R. It's hard to draw them both on the same one. Maybe I can come over here and draw big R. So big R goes to the outer edge. What's big R equal to?
No, that's equal to...
Is big R changing?
No.
It's not. So what's...
No, it's equal to the lines that it's on. So y equals 12 and negative 12.
The big R doesn't change, so if it doesn't change, a mathy word for that is constant. It's just 6. That sort of matches with, we said the outside looked like a cylinder. It has a constant outside radius.
Oh, I guess we're looking at that. Oh, okay. If you look at that big one on the end, it's just that all the way down.
Oh, that's a good idea. Look at the big circle. Circle.
It is the same all the way down. So it shouldn't have an x in the expression for big R, because it's always 6.
So little r equals 2x.
Little r is changing though, so it does need an x in it, but be careful.
It's 1/2. It's like reverse 2x.
It's reverse 2x. That's not a bad way to say it. 2x would be the bottom side of it. It's getting too many things down here.
6 minus 2x.
That's it. That's exactly it.
What?
Okay, 2x is this piece, but I don't want this piece, right? There's 2x, but that's not little r. Little r is on the other side of that. Little r is 6 minus 2x.
So r plus 2x equals 6. So it becomes 6 minus.
Yeah. Little r plus 2x is always 6.
Okay, cool.
That's true.
I'm so smart.
I don't know if that's helpful, but it's true.
Yes, I need to try
Why is it 6 minus 2x?
Because 2x is the height up to this line, right?
Oh.
But that's not what r is. R is the other side of that. Little r is this side of it.
Got it.
So little r is 6 minus 2x.
Got it now.
So big R squared minus little r squared dx. The line y equals 8. Let's see. Well, let's draw the base first. Again, the base is the same shape as the others. It might look different because the scale is different. But it's still that bottom triangle. Y equals 8. Now when I flip it, or when I rotate it, where's this point going to land? That point A. Kind of drew it already. It's not on the axis. In fact, it's 2 below the axis, so it needs to flip to 2 above the axis. So draw the base, draw the reflection, and then draw the circles.
No, I don't want
Base, reflection, circles to help you draw that BRC. I don't know. Base, reflection, circles. So, how would you describe this shape? It's still, you took a cylinder, you stuck a pencil in, but instead of stopping at the bottom, you poked all the way through. Now there's a hole in this. There's no tip on the pencil, but you went all the way through. So there's a hole in this cylinder. Like if I turn this sideways, this is like a funnel, like a thick funnel, but the water is going to flow through there.
Why are there leaves? Like, why'd you draw 2 and 1 on both ends the same?
You're right. I should have drawn it on the other end, on the other one. I usually try to draw the circles on both ends and then one in the middle to help me see if it's a disc or a washer to start with, but then also what's big R, what's little r.
This one is all washers.
Always draw the R from the axis. Maybe that's helpful too. R is always from the axis. So big R. Is big R changing or is big R constant? Big R is constant. And what's it equal to?
6. Oh, 8. What? Yeah.
Which one?
Don't worry about it.
8. Big R is 8.
That's what I was.
Little r from axis to edge there, little r, it's changing. 8 minus 2x. It's real similar to that last one, except it's 8 instead of 6. So adding up all the washers. You're right, it's washers all the way down. Although the last one was washers all the way down. Oh, I guess the very last one you could say is a disk. Well, not last one. Here it's definitely washers all the way down. From 0 to 3. Big R squared minus little r squared. And you notice we've stopped even putting them in the calculator. It's like that. I trust you to put them in the calculator. It just takes too long. You can just leave them like that. Oh, it does say write and compute, but it just takes a while to type it all in. At that point, you're just letting the calculator do the work.
So if we left that on the test, it wouldn't be
No, I would. Well, it depends on what the directions say.
okay.
I would probably want you to finish that though.
Once you put like 1 in the calculator, it's easy for you to just go back.
Now you're right. I don't know if you heard that, especially video people. Once you put 1 in the calculator, like especially from B to C, like that's nearly the same thing. Just go, go up 1, hit enter, and change the 6s to 8s. All right, D. Again, let's draw the base first. Don't worry about the axis yet. Draw the base. And again, it's a little weird. It looks like it's a different base than the others, but that's because the scale is different. So we still got y equals 0, x equals 3, and y equals 2x. Our base triangle here. All right, this time we're going to rotate it around the y-axis. Okay, so we got to kind of change our brain here a little bit, right? Instead of rotating around an x-axis thing, we got to rotate, yes, this way. First job, though, is to just do the mirror part. So mirror the base picture across. Right, so just like a 2D thing to start with. Just fold it over, mirror it across. And then we'll put the circles on there. Big circles on this one. So this is another one where it's a cylinder with a cone missing from the middle of it. All right, big R, always draw from the axis out. Big R and little r, always from the axis out. So is big R changing? No, it's a constant. What is it equal to? 3, good. Big R is 3. Little r, is little r changing? Yes. Okay, now this gets a little bit tricky. Little r is left and right, not up and down. So little r is an x value. So little r equals x. Let's pause there and start writing the volume integral and see what happens. So pi, the easy part, big R squared minus little r squared. But what are the limits? Like what are we, from what to what? How thick are my slices? Let me ask it that way then. How thick are these? How thick are the washers here? They're infinitely thin, that's true. But are they dx or are they dy? They're y slices. We've done y slices. So yes, they're infinitely thin. That's a great answer, but they're dy infinitely thin, not dx infinitely thin. So now would you like to rethink how we're adding up the washers from what to what? 0 to 6. It has to be y values now. And plus the washers aren't stacked -3 to 3. The washers are stacked 0 to 6. So I'm going to stack my washers 0 to 6. Big R is 3. Little r, though, I said little r is x, but that's not going to work in the expression here, right? Because I need everything to be in terms of y. So what does x equal? Very nice. Y equals 2x, but I need to know what x equals for this line. Well, x equals y over 2. Let's put that one in the calculator. We haven't been putting many in the calculator, but let's make sure we can still do that one. Now, when we put this one in the calculator, there's a sneaky trick around. Actually, let me put it in the right way first, and then I'll show you the trick. So pi, math 9, our new favorite key in the whole calculator. Look at me doing algebra on my own. 3 squared is 9. Minus y over 2 squared dy. Double checking. Because the calculator is not going to do anything wrong. It's going to do what I tell it to do. Pi 0 to 6, 9 minus y over 2 squared dy. 113.097. All right, the trick, that's not a trick, but it saves a few keystrokes. Your calculator doesn't know if you're doing an X or a Y problem. So if you want to just say, you know what, I don't want to hit alpha Y every time. I want to use the X button. You can put it in there in X, just because the X is an easier key to hit. And it's going to give you the same answer. To some people, that's like, oh, great, I saved a few keystrokes. The other people are like, wait a minute, I thought this was dy. What are you doing? Don't mess me up. Either way.
So did this just like happen to be coincidence, or is it's the same answer as what we got for the x-axis?
Yeah, it is. I think that is a coincidence.
Okay.
It is. The A and D gave us the same exact answer, and they don't even really look the same. So, well, I don't know that I'd go coincidence. I would just say I don't understand why they ended up being the same. Especially since one's a cone and one's a cylinder with a missing cone. So it's not even like they're both cones. Kind of weird. Why don't you see if you can take letter E? There's my picture. So the outer radius is the outer radius changing? Is big R changing? Yes. What about little r? There isn't a little r, so you can either put 0 or just say NA or leave it blank or an X. But big R. Big R. Big R is not measured from an axis, so I think I need like kind of a helper side over here. Right? That would be X. That would be X. So what's big R equal to? Well, let's start with 3 minus X. Because it's 3 to the axis 3 minus x would give me r. Oh, I'm taking dy slices again. So 0 to 6 dy. That means 3 minus x isn't good enough. It's not really wrong, it's just not right. I mean, it's not good enough yet. Because what did we say x was equal to? Y over 2. So 3 minus y over 2 squared with a pi. Let's jump to 3a. Why don't you see how far you can go with 3a? Oh, great. Draw the base first, then draw the axis, then flip it, and then start thinking about what the shape looks like. So base first, then the axis, then the reflection. The bark method. I was just making this up. Base, axis, reflection, circles. This is for the dogs, right? The bark method. Okay. Base, axis, reflection, circles. Base is that triangle looking thing up above into the first quadrant. Axis is x-axis. Reflect it, so I draw the 2D picture first, and then I put the circles on it to make it look 3D. Big R and little r always come from the axis. So there's little r. Well, I guess we should do big R first. It comes first in the list there. So is big R changing? Yes, and what is big R equal to? Either one is right. Y, it is a y value, but since I'm slicing dx, maybe it helps to start the. I'm slicing dx. My washers are stacked up in the x direction, so I need to use 1 plus square root of x. So it's not really wrong to call it y. It's just that won't work when it comes to the integral part. How about little r? That's just 1. That's 1 all the way down. The inside radius is 1 all the way down. And you're ready for the calculator at that point. Let's try B. Y equals 3. I don't care about y equals 3 first. I care about drawing the picture first. Base, axis, reflection, and then the circles. maybe it's just me, but there's something satisfying about a well-drawn 3D picture. See if you can figure out big R and little r. Again, big R is constant, so it's just 2. Little r is changing. It's 3 minus the y, or the y1, whatever you want to call it. But I can't use y because my slices are x. I've got to have everything in terms of x. We haven't really been doing this, but maybe it's helpful to start the, like after you get the picture, to start the integral. That way you'll know those washers are stacked up in the x direction, so this is a dx problem. So 0 to 4, and that means everything in there has to be in terms of x. I guess you could clean that up a little bit if you wanted to, make it 2 minus square root of x, but you could also just leave it as is. Right, that's the calculator's job to handle that stuff, not mine. Although, if it's easier for you to handle the algebra than to type in the extra stuff in the calculator, then... Oh, did I mess that up? No, I think it's 0 to 4. My washers are stacked up from 0 to 4.
Because they gave us the x equals 4.
Right, because they told us to stop at 4, at x equals 4. Let's do 3D. Again, base, axis, reflection, and then worry about R. And again, it looks like a different graph because the scale is different, but that's the same picture as all the other bases. Okay, my axis is up and down, so this is one of these rotations. But first job is just the geometry job. Copy it over, reflect it over. Probably did that in geometry and algebra, like here's a picture. Draw it if it's reflected in the y-axis. Base, axis, I've reflected. Now I'm ready to draw some circles. I don't know, maybe it's helpful to start with the integrand after you do that. Make it that far. Like, are my slices, is this a dx problem or a dy problem? My washers are stacked in the y direction, so it's dy. So that means I'm going 1 to 3 now. And it also means everything in there has to be in terms of y. I'm going to press pause. You see if you can get big R and little r. Big R is a constant 4, little r is equal to x, but x is equal to y minus 1 squared. So big R squared minus y minus 1 squared squared. Okay, we'll stop there. All the examples are done in Schoology. I would say, again, we're not doing anything new on Friday. I'll just work some of these. So I would switch to the homework and start working them and start trying them. You don't have to actually type in to get the numbers. Once you have an integral set up, then you're good.